Welcome back. Now, if we press play, we have our log message spamming the output log. And if we click in the viewport and press the W key, we see the value 1. So our move forward function has this value being passed into it every single frame, and its value changes depending on whether we're pressing or not pressing the W key. We're going to use this information to move our bird. So let's do it. So how do we move the bird? Well, we know of functions like add actor world offset, but that's not typically how we move pawns. We move pawns through something called a movement component. So here's how it works. We're going to make an if statement. And in the if statement condition, we're going to check to make sure value is not 0. So we can say value is not equal to 0.f. Now we know that we should have a controller possessing this pawn. So any other pawns in the world who might not be possessed should not be moving forward. So we can also place another condition in here. So I'm going to wrap this value is not equal to 0 in parentheses. And before checking that, we'll place an and here with another pair of parentheses. And in this pair of parentheses, we're going to check to see if our controller is not a null pointer. So how do we do that? Well, the pawn class has an inherited variable called controller. So we can say if controller is not equal to null pointer. So that's how we can check our controller. Now, you may be aware that if a pointer is null, then we can simply check its value directly. So if I go ahead and replace this parentheses with simply controller, well, this would be the same thing. Now, if the controller is valid and value is not 0, we want to move forward, which means we need to know the direction to move. Well, we know about getActor forward vector. If we call this, then this returns an f vector, and we can store this in a local f vector variable called, say, forward. So now that we have the forward vector, we can use this. So the way to use this is to call the function that the bird class inherits from a pawn called add movement input. And add movement input requires a direction. We can use forward. And it also requires a value. Now, it's called scale value. See this? Scale value is an input parameter of type float, and by default, it's set to 1. We also have a Boolean called bForce set to false. That's whether or not we should use force. Now, if we're not using force, then we're simply adding a direction value scaled and also passing in value. Now, value isn't going to scale this vector by making it longer or anything like that. Add movement input just cares if value is 0 or negative or positive. If it's 0, add movement input will do nothing. If it's positive, add movement input will consider this forward vector as is. And if it's negative, then add movement input will consider the opposite of the forward vector, essentially the same vector pointed backwards. So what does add movement input do? Well, it takes this direction and it passes it off to the movement component. So this movement component is something that handles all the movement for us. So let's see how this works. Let's go ahead and save all and hop back into the editor and hot reload. And with a hot reload finished, we're about ready to test this out. But before we do, I'm going to close the output log and open my content drawer and find the blueprints folder, go into pawns, and open my BP bird. And open the full blueprint editor by clicking that here. And the reason we're opening this blueprint is because add movement input passes that direction off to the movement component. But as you'll see here in the components panel, we don't see anything called movement component. And that's because pawns by default don't have movement components. They don't automatically get one. So we need to add one. And we can click plus add here to add a new component, and there are multiple types of movement components built into the engine. Now, the one I'm interested in is called floating pawn movement. So let's select that. And now we have a component called floating pawn movement. This is a floating pawn movement component. And if we select it here in the details panel, we can change all sorts of properties about floating pawn movement. We have a max speed. We have acceleration, which determines how quickly we start moving. Deceleration determines how quickly we stop moving. And then there's turning boost. This gives us an extra force when we're changing direction. Well, we're going to leave all of these settings at their default values for now and compile and press play and click in the viewport and press the W key, and we started moving. Now, this is a little frustrating because we can't really see our bird, and that's because, well, we're basically attached right to it, and generally it's a good idea if we have a camera that's offset so we can actually see the character or pawn or bird that we're controlling. So it would be nice to add a component for that. And also we'd like to be able to look around and control where we're flying because, as is, we can only go forward. And if I bring that bird off to the left here and enter rotation mode and rotate it by 180 degrees, for example, and press play, well, now we can see what's happening. And if we press the W key, we are moving forward, but that's about all we're doing. So in the next video, we're going to add a camera and offset it from our bird so we can actually see the bird while we're moving. But before we do that, before we wrap up this video, I'd like to open project settings again and take a look at Move Forward and notice that we have the W key assigned to it. But some games let you press the S key to go backward in your typical WASD movement. Well, I'd like to show you just how easy it is since we've already set this up. If we go ahead and press plus and click this keyboard icon and hit the S key on our keyboard, we can change the scale for the S key to -1. Now, if we do that, then when we press play, we can move forward as normal, but if I press S, I'm going backward. And that's because that scale value is set to -1. So what that's doing, if we go back and look at Move Forward, is setting our value input parameter to -1 when we're pressing the S key. And if it's -1, then we're calling Add Movement Input, passing in the forward vector, but value is a negative, so it's flipping this forward vector and sending us backward. Now, I just want to emphasize here that if you had, say, a value of 2 passed in here, you're not going to go twice as fast. Add Movement Input just passes the direction off to the movement component. And we saw in our floating pawn movement component that we have speed and acceleration and all these properties here. So the movement component just expects a direction. It handles all the rest. It handles calculating acceleration, deceleration, how fast we can actually go. If we set our max speed down to a value of 200 and press play, well, now we're going to go a lot slower. But I'd like to keep it at 1200. That's a pretty good value. Now, acceleration can be lowered and we'll get a slower running start. For example, if I set this down to 200, then press play, then as soon as I start going forward, you'll see that we kind of ramp up. And as soon as I stop pressing the key, we stop very rapidly, and that's because our deceleration is so high. If we set that down to 200, then we'll sort of see the same thing. If I ramp up to start and then I stop, then we sort of slow to a stop. So I can start going backwards and release, and you see we sort of glide to a stop. So that's how acceleration and deceleration work. I'm going to go ahead and set acceleration back to 4,000, deceleration back to 8,000, and I leave it up to you as an exercise to play with these and see what maybe some of the other parameters do to affect our floating pawn movement. All right, great job. In the next video, we'll add a camera and see how we can offset our view so that we can actually see our bird and perhaps work on implementing a way to steer the bird so we can control where we fly. Great job. I'll see you soon.